we're going to touch on another one of my passions here, and it's a growing passion. I still consider myself a bit of a beginner when it comes to containers. But we're going to talk about Kubernetes and Docker. So just kind of want to check what's going on. Who here has worked with containers before? OK, that's actually about as expected. Don't worry, we're going to do some overview. So if you don't know the intricacies of containers, you'll get a good summary, hopefully. So what are containers, and how can they help us kind of be better developers? Well, I'm going to start with the summary, because that's the most important part, obviously. A container raises the abstraction level for how you develop. So when you're developing on traditional virtual machines, you are actually interacting with idealized hardware, right? You're interacting with the operating system, the network, the disk, what have you. And it's fairly well tied into the environment on which you're running. You have to know the ins and outs, whether there are any gotchas, et cetera. And what happens is this becomes kind of like an octopus intertwined with the environment. And that's not really ideal. So containers separate out your application from where it runs. And that's like the most powerful thing that I can say about containers. So instead of developing on top of idealized hardware, you're developing against an idealized operating system, a static Linux environment when you're developing with containers. So it allows you to really develop in a more generic way that can run more places. And you wind up with this kind of hermetically sealed, which I think is an awesome phrase to describe containers, a hermetically sealed application. And this allows you to really dive into what's going on in your application because it's lifted up outside of the environment. So we'll get into a little bit more detail. So why do we care? Why do developers care about containers? Well, the first reason is stress. Who here is stressed? I am so stressed I can't even tell you. We deal with stress on a day-to-day basis, and oftentimes it comes from our deployments, right? I remember I once had a bug in my production system. This is before I joined Google. I once had a bug in my production system that only existed there. It didn't occur in my development environment. It didn't occur in staging or test, only in production. And that strikes fear into the heart of a developer, like ice running through your veins, because it's so hard to debug. It's an environment issue. And I was combing through code, and I actually didn't find anything because the bug was not in the code. It was in the build scripts, which you can argue is code. I'll grant you that. So these reliable deployments, when you're operating with containers, it means that your development environment is the same as your staging or test environment, is the same as your production environment, because you're developing against that idealized static Linux environment. The surface area for bugs, while you can still obviously introduce them into your applications, it's going to be dramatically reduced. And that just makes people happy and lifts stress. So containers, less stress. The other reason is that it is portable. You can take a container with your deployable application and move it from one environment to another. So you may decide to run on Compute Engine or another cloud provider. But with containers, you can easily move between different environments, different providers. And this is awesome. This is great because what it means is you can pursue a multi-cloud approach if you want. And oftentimes that may indeed be the path you take. You can decide to do a hybrid cloud, a private cloud, and then switch from one to the other when the case may be. So we've done a lot of work with Compute Engine to make sure it's awesome and that it's a great place for you to develop. But we want you to be there because you want to be there, not because it's hard to move. So you get to pick your cloud, where you run, based on its merits. And that puts the power back into your hands. And that's fantastic. That's the way it should be. And the last reason is because because microservices. Because containers make it easier for you to separate out your application into smaller components that are far more like Lego than monolithic structures. And this means you can manage them much easier. You can debug a microservice far more easily than you can debug a monolithic application. It makes it easier to upgrade, so you can slowly, incrementally improve what you're offering to your users. And make sure and know that your surface area for regressions is low. And then, of course, you can mix in other services easily and safely. However, if you do encounter a regression based on an upgrade, containers also make it really easy to roll back. So this is a slide that you did see in the keynote, but everything at Google runs in a container. Everything. Like, we've been long-term fans of containers. And why is that? What do containers give us that we love so very much? Well, we've been doing these kind of hyperscale deployments, these hyperscale services. And to be most efficient, we need to make use, as much use of our resources as possible. So the machines that we run, we want them to be as close to 100% capacity as possible. And containers let us do that. If we have a really high priority job that we want to run, we can put that on the same machine as a low priority job, but in their own containers. And that means that the low priority job won't consume the resources of the high priority one. And the resource isolation means they're not going to run up into each other on another level. It also means that we get a lot of insight into how our applications are running. Is one application eating up a lot of disk space? It could be, and because it's running in its own container, we can drill down, find out which application that is and why it's doing that. It gives us resource accounting. And then we can, of course, talk to our engineers and create that nice feedback loop between how an application runs and how it's developed. So, like I said, we're big fans of containers. We run over 2 billion per week. So things like Gmail, Search, Drive, all run in containers. And in fact, our compute engine, virtual machines, run in containers as well. Which is a really, that's something. We're saying we're throwing our experience, our weight behind this technology, telling you that we're big fans. So let's talk a little bit about the stack at Google. So the Google Cluster Management Stack is comprised of these two sections, the section in blue and the section in what I'm going to call marigold, because that seems like that color. So at the base, you've got the managed base OS and the node container manager. So these two things are what are deployed on every single machine in our data centers. Every single one. The scheduled containers is everything that we want to run on our machines. And the cluster scheduler figures out where and when that happens. So let's talk about the blue section. And this is essentially what we've released in May as our container-optimized virtual machine image. And that is a mouthful. So this means that you can go from an imperative approach to a declarative one. And what does that mean? So we might be at the point where I say, sorry, I apparently will say sorry, where I say to a machine, I want you to run this software, do these tasks, and shut down. If I want to move that into a declarative approach, you say, I expect this machine to be running, doing these tasks, and shutting down once that happens. It's a really subtle change, isn't it? It's hard to parse. It's almost more of a psychological shift than a technological one. But it means you can go to expecting what your machines should be doing instead of feeling like you have to tell them every time. So what does that actually look like? Let's go through a command line example. Who here uses Apache Web Server? nginx? So nginx is a really lightweight web server. It's easy to install, easy to spin up, and we've been using it for some of our examples lately. We're going to call in to the Cloud SDK, gcloud. We're going to create a compute engine instance, a compute engine virtual machine. We're going to call it my nginx container. And we're going to take some configuration information from this containers.yaml file. We'll locate it in a zone. We're going to use a small instance. It's a lightweight web server. We don't need a big one. Best practices always use the right tool for the job. And then we're going to use our container-optimized VM. And that's what that -- image, really long string that I don't really want to say. And we're going to create a container running nginx. Pretty simple. But what is in this containers.yaml file? That's it. We've got a nice structured specification of what we want to happen inside of the container. We want to use the nginx image. We're going to call it dub, and we're going to open up a standard port to serve traffic over. We're mapping 80 to 8080. And that will let us go ahead and stand up a nice web server inside of a container. But let's make it a little bit more complicated, not very much. Let's say, OK, but let's go back to the best practices. We should also open up HTTPS. And we can do that simply by adding another section under the ports and open up port 443. And so now we have a nice web server serving traffic over HTTP or HTTPS. Let's get a little bit more complicated. Now, this is great for a web server. But what if you've got kind of two functions, maybe sharing some data, but they comprise one overall application? So that's what we call a pod. We've got the web server, the dub, and we've got a data loader that takes in, say, new things that you want to serve. So it's going to write that to the data shard. They work nicely together. And they can actually function as a unit with this thing we're calling a pod. So as you can see, the web server, dub, mounts up our data shard, but it doesn't need to write to it, so it's just going to be read-only. Whereas the data loader does need to write, so obviously we don't have that line. So that's kind of the conceptual unit of a pod. What does this kind of look like? Well, on the virtual machine itself, we've got a couple of sections. We've got what Google provides, and we've got what you provide. And on the left is all Google provided. You can see it's kind of haphazard. We've got the managed base OS, we've got the monitoring agent, the logging agent, but we've also got Docker running. It's already running on our container-optimized virtual machines, or virtual machine images. It's also got a couple of processes running, like SSHD and init. On the right-hand side is the container environment that we talked about, right on top of that base OS. And we've got the user app, what you create. So let's step out back into scheduling. So the job of the cluster scheduler is to figure out what resources are available to us, or to it, and figure out where the best place is for you to run your job. So you can say to it, I've got, let's see, I've got X, I need X cores, Y RAM, and let's say Z amount of disk that I want associated with this container. It'll say, OK, cool. That's awesome. I think I can do that. Let me go find a place. And it'll find a place where it can run happily. And this is where Kubernetes comes in. So Kubernetes is an open source project. It's developed out in the open on GitHub. You can go clone it, fork it today. And we'll give you a link to that at the very end, so don't worry about searching. And it's actually ancient Greek, an etymological sidetrack, for pilot or helmsman. We're a little bit of nerds at Google. I don't know if you could tell. And what it does is it's a cluster manager. It's what we were talking about in the marigold. Do we have any gophers in the room? How many of you are confused by the term gopher? OK. So gopher is what we generally call people who develop in Go. So you'll be happy to know that Kubernetes is actually implemented in the Go programming language. And it allows you to manage applications and not machines. So we developed it out in the open for a couple of reasons. We don't think we can go it alone. We want to make sure that we gather the expertise necessary to make this an awesome open source project for everyone. That means being able to run it wherever you want, whether you want to run it locally, on your own cloud, on Google's cloud. Obviously, we've done a lot of work to make it run great there, or on a different provider. And like Tom just mentioned, we've gotten a lot of interest from other companies who are becoming active committers on the project, and that's so awesome to see. Microsoft, IBM, Red Hat, Docker, Mesosphere, SaltStack, CoreOS, and I've run out of breath, so we're going to stop there. And you too can submit pull requests as well. You can become a contributor for Kubernetes. So I encourage you to check it out. So what does it actually look like? So with Kubernetes, it provides a scheduler layer. And it lets you schedule work in the way that we were talking about, in a declarative manner. But you don't need to know what machine you're running on. That's almost irrelevant, right? So you interact with the Kubernetes master/scheduler whenever you want to interact with it. And so you tell it what pod you want to run. In this case, we've got a web server and a log roller. And it'll schedule the work out to machines. And if all you need is a few of these pods, maybe you're developing a small application, that's great. That's probably all you need to do. But if you've got a more complex application, that's going to be too much to handle, at least rationally. So right here, we've got a bunch of pods. We've got some front ends. We've got some back ends, hopefully all working in some sort of harmony. But we want to make it easier. And that's where labels and selectors come into play. And it's a really simple concept. We assign labels to pods. In this case, we've got two types of labels. We've got front end and back end. And here, we're going to select all of the front ends that we've got running within our Kubernetes cluster. So you can see all of the front ends are lit up in green, and the back ends have been deselected. But wait, there's more. You can do a more complex query. And you only want to select the front end, the production front ends. So you can select on both labels, the stage and the role label. And again, 3 front ends have dropped away, and we're left with all of the production front ends. OK, so now you have a set of pods. You can interact with a set of pods in your Kubernetes cluster. And you want to do something cool. And you can do that with the replica controller. So this takes a template, this kind of predefined cookie cutter type thing, and a label selector, and a set of pods, and a number of replicas. And what it does is it keeps maintaining the containers, the pods, to comply with that cookie cutter. So right here, you can see we've got 4 replicas, and lo and behold, we have 4 production front ends. OK. But you know what? I decided that's way too many. It's a small application. I don't need 4 front ends. I want to drop it down to 1. So the replica controller is constantly monitoring and saying, hey, is my expected state the same as my actual state? And in this case, I want to change it to 1. So I update, and the replica controller will say, oh, wait, I've got 4. I only need 1. That's far too many. Let me kill 3. And we're left with 1. And then I've clearly made a drastic error. That was not a good idea to drop it down to 1, so I'll increase it to 3. Again, our expected state is different than our actual state. Let's up it. Let's create a couple more containers until our state is the right one. But right now, we've only been talking about the front ends, the production front ends. And obviously, there were back ends in our cluster as well. So we need a way to access both in an abstracted manner. We need a way to access our production front ends and our production back ends in an abstract way. And that's what we do with services. So a service is basically a way for you to access your set of pods. And you access them through an endpoint. In this case, for the back ends, we access them on port 9000. And the front ends can talk to that endpoint. It doesn't matter how many pods there are there. It's going to load balance anything that comes in over that port across the ones that exist. So it's a nice, easy way. Again, you don't need to care how many containers are running. You just need a way to interact with the ones that are. So who wants to do a demo? OK, awesome. So no demo in tech is complete without cats, right? Yeah, I didn't think so. So can we switch to the demo, please? Let me unlock my machine, and we will get there. Awesome. So these are our cats. And we've got a Kubernetes cluster running, a simple web server. And these are actually running on Compute Engine. And this is basically showing off what the pods are doing. So not necessarily your end goal here, but it's good for this purpose. But I do have a confession to make. I'm not a cat person. I'm sorry. I'm not a cat person. So what I want to do is replace all of these cats with pictures of a nautilus instead. That's so much cooler than cats. I'm sorry. So what I'm going to do is pull. We've got a data file that's telling us which picture to use. I'm going to modify it. And you can see here, currently it's pulling kitten.jpg. And we're going to make it Nautilus. Let's see if I spelled that right. Somebody want to spell check me? Now, what we're going to do is actually go ahead and build the Docker image. So I'm going to build it, build the container, and it's going to finish really rapidly. So I'm going to go ahead and push it. So it's going to go ahead and do this. But you'll notice that we still have our cats. It's not actually changing anything with Kubernetes. I could refresh the page. It's not going to matter, because we haven't told it to do anything. We haven't told it to update. So while that's actually pushing, because it takes a little bit of time, I'm just going to show you that indeed we are still serving up kitten.jpg. And in fact, if we take this away, you can see that we're running nginx inside of our container. So let's see, we're almost there. I'm like anticipating just a couple minutes. Not a minute, like a couple seconds, that would be insane. And we've finished. Now we can go ahead and interact with Kubernetes to update. So I've created a link to my command line to this utility. And I'm going to do a rolling update. As anybody who's done production updates, you don't want to do it all at once, because everything will go down. That's generally regarded as a bad thing, generally. So we're going to interact with the data controller, and we're going to do an update interval of 10 seconds. It is also way too fast for production. Everything will go down if you do this. However, since I've got less than 5 minutes to go, I'm going to go ahead and live life on the edge here. So it's going to interact with the Kubernetes API. We're going to go back here, and you can see already that we have containers dropping off. And as they come back up, hopefully we'll be serving an image that will contribute to my plan to replace all pictures of cats on the internet with pictures of a nautilus. Sorry, cat people. I apologize. So you see, again, because our update interval is so short, we do not have all of our containers running at once, all of our pods running at once. Clearly, you want to do something a little bit more sane as your update interval. So once it comes back up, it will pull down the image, and we've got the pods running. It hasn't yet started serving, so that will come back as things progress. But I do just want to show you, that'll happen in the background, I do just want to show you that we can actually, because these are just compute engine virtual machines, we can SSH into the VMs. So let's go ahead and do that. Let's SSH into Kubernetes minion. The thread is complete. 1. I've always wanted a minion. This is why I went to grad school. I wanted minions. So we're now inside of a Kubernetes minion. As you can see, my command prompt completely changed because I'm running a different shell. And we can take a look at what's going on. Let's do sudo docker ps. And you can see, because it's such big font here, but this is our nginx server. You can see we've got that. But let's go ahead. Now remember that that started with BD8, okay? So I'm going to kill it. That's pretty much all you get when you kill a Docker process. So let's go back and do a PS. Now you can see that nginx is not there. But hey, didn't we say we wanted 4 running at any given time? So shouldn't it come back up? And in fact, it did. And now it starts with EA9. So we have satisfied the replica controller's requirements. It monitored, it fixed, and we're good to go. So if we could switch back to the slides, please. So that's kind of the magic that is Kubernetes. It's a great open source project. We're excited to see where it goes next. So in summary, we've had a lot of experiences over the last 10 years with containers. And Kubernetes is really our effort to bring those experiences out into the open source community, as well as get other experiences and other use cases. So tell us what you want to see out of it. File bugs, file issues, and send us pull requests. We're happy to see them. So here are just some resources. This is our Kubernetes repository, our container-optimized virtual machine images. And we're on Freenode, so if you want to chat with us, it's Google-containers. Thanks, everyone.